So, today I'm going to teach you about special triangles. There are two types of triangle. Two types of right triangle. The 30, 60, 90 or the 45, 45, 90. So the 30, 60, 90 comes from a equilateral triangle. If this is 1, all sides has to be 1. And if you cut it in half, what's 1 divided by 2? It'll be 1/2. So your answer's right here. Now use the Pythagorean theorem to find out the last side. Right here. So you plug in 1 for hypotenuse for C equals A 1/2 square plus B squared. Square root of, this 1 squared equals 1. 1/2 squared equals 1/4 plus B squared. Now you subtract 1/4 on each side, and you'll get 3/4 equals B squared. Now you square root B squared. Square root both sides, and you get the square root of 3/4. Then that will just equal square root 3 and square root of 4, and the square root of 4 is 2. So here's your answer for this side. Now for the 45, 45, 90, you have two sides that's equal and one side that's longer than the others. This is what you call an isosceles triangle. So for the hypotenuse, you put in 1 equals x squared plus x squared, and x squared plus x squared equals 2x squared. Then you divide both sides by 2, then you get 1/2 equals x squared. Now you square root both sides, and you get square root 1/2 equals x. And you have to radicalize it. So you put it to a weird 1, so that's radical 2 over radical 2, and that will equal to radical 2 over 2. That's your x. Yeah. And yeah.
So today I'll be talking about the unit circle. So unit circle is finding. Oh my god.
Yeah.
Okay, so today I'm going to talk about the unit circle. So let's just say this point is 1. Okay, 1, 0. Okay, this point is the origin. This radius length is 1 because of this 1. Okay, let's make a line right here to create a triangle, a right triangle. This is a 30-degree angle. So let's find out the rest of these sides. So we all know a 30, 60, 90 triangle is half of a equilateral. So when this is 1, this will be 1/2. And this you multiply by radical 3, and you get radical 3 over 2. So this will be radical 3 over 2, and this is 1/2. Now let's find the cosine of this triangle. Cosine 30. Soka toa ka. Adjacent over hypotenuse
Excuse the monkey.
Adjacent, which is radical 3 over 2. The hypotenuse is 1. Radical 3 over 2 over 1 is just radical 3 over 2, which is the x-axis, radical 3 over 2. So let's find y by using sine of 30 degrees. Well, sine, so, S-O-H, opposite over hypotenuse. The opposite is 1/2. Length of the hypotenuse is 1 again, which makes this 1/2. Back to here, 1/2. So this is how you find the x-axis and the y-axis, and find all sides of this 30, 60, 90 triangle. This is how the triangle relates to the unit circle, and using triangles to find the coordinates for the circle.
So in a circle, there's 1 radian in this line right here, and this sine it goes to theta, and the arc is this part. If theta equals 1 radian, then the arc is the radius.
Okay.
1 radian equals 360 over 2 pi, which when you simplify it equals to 180 over pi, and to solve for this it's about 57.3 degrees.
Go.
So in a circle, it equals to 2 pi r, which r equals to 1. So 2 times pi times 1 is just 2 pi by itself. There are 2 pi radians in the circle, which equals to 360. To solve for it, you put 2 pi radians equals 360. 2 pi over 360 equals 360 divided by 360 equals to pi over a 180 equals 180. Yeah. Converting degrees to radians and radians to degree. So 1 degree equals radians times 180 over pi, and 1 radian equals degree times pi over 180. For example, in a circle, this triangle right here is a 30, 60, 90 triangle. To solve from degree to radians, you put 30 times pi over 180 equals 30 pi over 180 equals to 1 pi over 6. When you simplify it, so 1 pi is basically pi over 6. So 360 degree to 2 radians equals 2 pi r. R is just 1, so it's basically equals to 2 pi. 1 radian equals 1 pi, and 2 pi equals full circle, and 2 pi equals 360.